So Leetcode problem of the day, and here we bring the solution for you. Just in case if you are new to our channel, I highly recommend you to subscribe our channel so that you can get a daily updates on Leetcode problem of the day. So let's start with our first problem, that is find the first and the last position of an element in the sorted array. So what does this question says that they have given a particular array called as nums, which is sorted in non-decreasing order, and they will also give one target value, and what we need to find is we need to find the starting and ending position of that particular value. And most interestingly, if that target value is not present in my array, I have to return the -1 and -1, since there is no any starting and ending point for that particular value. For example, in the given array, what they have asked us to find the starting and ending position of value called as an 8. So here we can say that the starting position of 8 is 3 and the ending position of 8 is 4. So simply what I need to return is I need to return 3 comma 4, because 3 is the starting position of an 8 and 4 is the ending position of 4. Here in this example, you can say that they have asked us to find the target value 6. But the point is, we can see here there is no any 6 present in my array. So I have to return -1 -1, since there is no any starting position and ending position for the target value 6. So I hope so you understood the meaning of the questions. Now let's try to derive the answer for this question. Okay, now let's check out the brute force solution for the given problem. So what they have asked us, they have asked us to check the starting position and ending position of the key value called as 5. So here in this array we can say that 5 is starting at an index 3 and 5 is ending at an index 6. So I can simply return as 3 comma 6, right? But the point is, how can I come to know that on which index my 5 lies? So can I do a simple linear search so that I can check if that value is present in my array or not? So for that purpose, I got a two variable that is called as the first and the last, which are basically initialized to -1. So what I will simply do is I will come over here and check, is it equal to 5? No. Is it equal to 5? No. Is it equal to 5? No. Is it equal to 5? Yes. So I'll simply update my first index as it 3. Now I come across over here, it is 5, but I will not update my first index, but I will update my last index as it 4. Now come across over here, still it is 5, so simply I will update it to as 5. Again I will come here, it is still 5, so I will simply update it to as 6. Now I come over here, is it 5? No. So I will simply stop searching over here, and simply finally I will return the first and the last index, that is called as 3 comma 6. So simple, what we did is we had a linear search, right? But the point with the linear search is we got big of n time complexity. And what they have asked in the question is they have asked to write an algorithm which takes big of log n time complexity. So can we do it something better than the linear search? Let's try to check whether we can get a better solution that big of n. Okay, let's have an optimal solution for the given problem. But before we move on to the solution, I would like to inform you one important thing. That is, first thing, that whenever we got to find and sorted these two words in my question, always think of binary search, because we have to find might be a possible number or a pair, or the data is given us in a sorted order. So if the data is given in a sorted order and we need to find one particular element, which algorithm we use? Binary search. So the same algorithm we will be using to solve this question. Only a thing is we will be having a slight modification in order to get the answer. So we will be using a binary search to solve this question, since my data is in sorted order and I need to find whether this key is present, and if it is present I need to find the first and the last position of that particular key. So let's try to implement the binary search with slight modification. So everyone knows that what we do in binary search is we got high and we got low, and what we do is we simply find the mid. So if I find the mid, it would be 8 divided by 2, it would be 4. So my mid will be pointing at this position. Now I will check, is this a number which I'm looking for? Yes, I was looking for 5 and I got my 5. Now the question is this my starting position of 5? It might be or it might not be, because as you can see that there are still number of 5s present to the left of this 5, right? So can I say, if I'm getting the key at my middle position, there might be a possibility that my 4 as an index might be answer or might not be answer. So simply what I will do is I will simply store this value 4 in my first variable, right? First as my first occurrence. So I will simply store it as 4. Now, since there might be a possibility that there are still number of 5s can occur to the left of this 5. So simply what I will do is I will simply take this high to the left of my mid, to the left of mid. So I will simply bring over high over here. So this high get cancelled. So again I will find the mid. So again I will find the mid. So what will be my mid now? It would be 3 divided by 2. It will be 1 point something. So integer value will be 1. So I will be pointing over here. This is my mid. Now I will check, is it a value which I was looking for? No, because I was looking for 5 and I'm getting as a 3. Now I will check, is my 3 less than 5 or is my 3 greater than 5? My 3 is less than 5. So I have to check to the right of the 3. So what I will do is I will simply take this low to the right of mid value, that is simply over here. So again I will erase this low from this side and I will bring it to the right of mid. So my low will come over here and my mid will change now. Now again I will calculate the mid value. So what would be 2 plus 3? It would be 5 and equal to 5 divided by 2. It would be 2. So my mid will be pointing at position 2. Now I will check, is this the required value? Yes, I was looking for 5. Now is it my rightmost or the first occurrence of the number? It might be or might not be. So my index is 2. So I will simply update. Earlier it was 4. So I will simply update it to as a 2. Simply I will update it as a 2. Now again I will check, there might be a possibility is that before this 5 there might be occurrence of 5 can takes place to the left of this 5. So I will change the position of my high to the left of my mid. So to the left of my mid. So my high will come over here. And as you can see, my high has crossed the low. So I simply need to stop over here. So can I say that from this I got the first occurrence of my 5, that is at index 2. I got an index 2. So what we simply did is we simply find the middle element. If my middle element is equal to 5, I store that index value because that might be my answer or might not be my answer. Even if it is my answer, I will check to the left of this 5 that there might be a possibility that still number of 5s can occur to the left of my mid value. So I will simply transmute my high to the left of my mid and I will check whether still there 5 exists or not. So I hope so you got for solving the left occurrence, or simply I can say that the first occurrence of that particular number. The same thing I would use to find the last occurrence, right? What we will do is again I will keep my low over here and I will have my high over here. So say for example this is called as the last occurrence. So initially it is -1. So I will find the mid. So what will be mid? It will be 8 divided by 2, 4. So mid will be pointing over here. Mid will be pointing at index 4. So I will check, is this a value which I am looking for? Yes, I was looking for 5 and I got the 5. So this might be my answer or might not be answer, because there can be possibilities that after this 5 there can exist a 5. So simply I will store the index 4 as it can be my answer and I will simply shift my left to its right of the mid, because it might be possibilities that there are still number of 5 are present after this 5. So I will simply take this low to the right of my mid, that is over here, and I will erase the mid. Now again I will calculate the mid. So it would be mid would be, that is 5 plus 8 divided by 2, it would be 13 divided by 2, it would be 6, right? So my mid will be pointing at this position. Now I will check, is it a value which I am looking for? Yes, I got the value. So it might be my answer or might not be my answer. So I will simply update my last as my 6. And there might be possibilities that there still number of 5 can exist to the right of this 5. So I will simply transmute my low to the right of my mid. So low will come over here and my mid will change, right? Now again I will calculate the mid. So it would be 7 plus 8 divided by 2, it would be 15 divided by 2, it would be 7. So my mid is pointing at position 7. Now I will check, is it my required value? No, but the point is my 5 is less than 6. So I'll simply transport my high has crossed the mid, right? So mid will get vanished. Calculating the mid, we can say that my high and low are crossed each other, so I need to stop. So here I will get the final answer as last, that is 6. Is it a 6 is my index with the last occurrence of 5, and the first is 2, that is the first occurrence of 5. So we got the required answer. So what we did is we used a 2 binary search, one to find the first occurrence and one to find the last occurrence, because the point is in one binary search we cannot find both the position. We can either find first or we can find the last. So that's the reason why we need to have a 2 binary search. So this is the perfect solution to find the first and the last occurrence of the solution. Now it's time to check the C++ and Java code. Now let's look at the solution for the problem. So this function is basically used to find the first occurrence, and this function is basically used to find the last occurrence. So what we basically do is we are defining the two variables start and end. So this will be my start and this will be my end. So again I will be initializing the index value as -1, because there might be a possibility that the value which I am looking for is not present in my array. Now say for example in this array I need to check the first and the last occurrence of value as 3. So again I will check, is my start is less than equal to n? Yes. Then I will calculate the mid. So what will be my mid value? So mid value by 3. So I will be pointing at here. Now I will check, is it my required value? Yes. Is my required value? So in index simply I will update as index 3, because as I told you, this might be my answer or might not be answer, because there's still possibilities that my 3 can exist before that 3 as well. So I'll simply transfer this my end to the left of my mid. So what I will do is I'll simply brought end over here, and this mid get cancelled and this end will get cancelled, as you can see in this. Even if I got the required target, I shifted my end value to its left so that I can find the first occurrence of the element, because this might be a possibility that before these 3 there are still number of 3 can exist, and this is what we did. So again we calculate the mid over here, that is how what will be the mid. So 2 divided by 1, it would be 1. So my mid will be pointing at this position. Now we'll check, is it my required value? No, because I was looking for 3. So this condition get false, so I will come out to else. Now I will check, what is my mid value? 2. Is it my less than key, that is 3? Yes. So this if get true, and what I do is I'll simply shift my start to its right of the mid. So my start will come over here. So this will be my start. So from this position start get cancelled and mid get cancelled, and again what I do is start is less than equal to end. So again I will calculate the mid. So again it would be 2 plus 2 4 by 2, it would be 2, right? So I will check, is it my required value? Yes. I was looking for 3 and I got the 3. So this might be my answer or might not be answer. So I will simply store that index as 2. Now what I will do is, since this condition gets true, I will shift my end to the left of my mid. So my end get cancelled over here and it comes this. Now since both have crossed each other, this condition get false and we will come out of the loop. So we got the first occurrence of the index, that is 2. As you can see that the first occurrence of 3 is 2. The same thing we did in the right, rather than shifting to the left we shifted to the right, so that we can find the last occurrence of that particular number. So I hope so you understood the meaning of the question and you understood the thorough detailed solution. If you talk about the time complexity of this question will be big of log n, because this will be taken big of log n and this would be taking as log of n. So average time complexity would be big of log n. So I hope so you understood this question clearly. Just in case if you are new to our channel, I highly recommend you to subscribe the channel so that you can come across daily Leetcode solutions.